In this video, we are solving the LeetCode task number 2894, divisible and non-divisible sums difference. We have given two arguments, n and m, integers, where n means that we are considering elements from 1 to n, and m that for each element in range from 1 to n, we need to check if it's divisible by m. And our task is to find the difference num1 minus num2, where num1 is sum of all elements from 1 to n that are not divisible by m, and num2 is the sum of all elements from 1 to n divisible by m. Let's look at the pseudocode first before diving into the C# implementation. So we can arrange two lists. First, L1 with elements not divisible by m, and second list, L2 with elements divisible by m. We can arrange these two lists by going through elements from 1 to n, and if element is not divisible by m, add it to the first sum. Otherwise, else, add the element to the second sum with elements that are divisible by m. Note that here we cannot use an array instead of list because at the beginning we don't know the exact number of elements in lists. What we could do, we could first determine the number of elements that are not divisible by m and define an array of n1 elements instead of list 1, and the same for n2 and array of n2 elements, number of elements that are divisible by m, instead of list 2. But here it's easier to use the list because we don't need any pre-calculation in that case. Then we can find sums num1 and num2. Num1 is the sum of elements in L1, and num2 is the sum of elements in the second list, L2. And finally, we can find the result and return it. Now, let's transform this pseudocode to the C#. Notice that elements in these two lists are actually numbers from 1 to n. So both lists will be lists of integers. For iterating through elements from 1 to n, we are using for loop in this case. Also, we could use while as well by first initializing element to 1 to start from 1 and iterate while element is less than or equal to n and do the job. But here we cannot, for example, use for each, because to use for each we need the collection to iterate through. So we need to explicitly create a list of n elements, which is big O of n space complexity, and then iterate through all of them. And there is no need to occupy additional space in memory just to iterate through elements when we can do that using the simple for loop and without any explicit data structure in memory. So here we will use for loop. We can introduce a bool variable is divisible to check if our element is divisible by n, if the remainder is equal 0. Two equal signs are used for the comparison. If our element is not divisible by m, exclamation mark is used for negation, we need to add the element to the first list. Else, we need to add the element to the second list. Further, we need to specify the type and call the sum method for list 1. Here the same, but for list 2. And we need to define the type for result as well and return the result. Let's now run our code against these 3 test cases. Good. All 3 tests have been accepted. Let's now try to submit the code against all possible tests. Everything passed successfully. Our solution has been accepted. Now, let us discuss the time and space complexity of this solution. First, time complexity. So we are declaring 2 lists which has no impact to the time complexity. They are constant operations. In for loop, we need to iterate through elements from 1 to n, and inside the loop, all operations are constant, which gives us big O of n, linear, times complexity in total for the whole for loop. Further, defining number 1 and number 2 can seem constant, but it's important to be aware that in the background, we have the process of calculating the sum of whole list. So we need to iterate through all elements in list to calculate its sum. So this is big O of n operation and this one as well. So we have 3 big O of n, but it's big O of n in total, just linear time complexity. Space complexity is linear as well due to lists L1 and L2. Everything else makes the constant space complexity. Here, you can think of creating a bool variable inside the for loop n times, which is true, but it's still big O of 1 space complexity, not big O of n, because after the end of each iteration, our variable doesn't exist anymore. We are creating new variable each time, and we won't have any variables creating in memory at the same time. So it's big O of 1 space complexity for this part, and in total for the whole for loop is big O of 1 space complexity. And we have big O of n space complexity for our whole solution because of these 2 lists. Let's now see how we can improve our solution in terms of complexity. The time complexity couldn't be better than linear, since we need to go through each element from 1 to n to check if it's divisible by m and add it to the appropriate sum. But when it comes to the space complexity, we don't need to create lists 1 and 2 explicitly. When we check the divisibility, we can add the element directly to appropriate sum, instead of adding first to the list and then adding to the sum later. So now we still have linear time complexity, but we have the constant space complexity in this case. Let's run and submit our code now to compare the complexity with the previously generated one. Okay, good. And so we can improve our code further to reduce a bit number of variables and calculations. At the end, each element not divisible by m has been added to the final result, and each element divisible by m has been subtracted from the result. So we can have only the resulting variable. And here, if divisible, add element to result, and if not divisible, subtract element from the result. And here, our result variable is already prepared and just need to be returned. Let's run and submit to check this solution as well. Okay, good. So the time complexity is here still linear, since we're iterating through all elements anyway. But this solution may be a bit clearer and easier to understand. But performance improvement is really minor and is still the same as previously mentioned one. It's the same class of complexity, linear. Now, let's take a look at data structures, algorithms, and complexity we've covered. We mentioned integer numbers and some basic operations on them. Further, we used list for implementation and discussed why not to use array in this case. We created list and added some elements to it. Since we used for loop and iterated through each element, we created an iterative solution with the brute force approach. We just were iterating through whole array without any performance improvement. We covered time and space complexity as well. Time complexity is linear, and we discussed both linear and constant space complexity solutions.